to pause and rewind this video is I'm going to show you a sample mole ratio. So they said in simple integers show mole ratios for, I'll just do a sample one, the moles of silver produced compared to moles of copper reacted. Please do your ratio in the same order that it was given. You can also abbreviate moles with the symbol N. We can't use M because M stands for mass, but we can use N. It stands for number of moles, and that kind of makes your work a little shorter. Your moles of silver we had would depend on what your yield was. Well, let's do silver nitrate because we all started with about the same. So if I started with my 1 gram of silver nitrate, if you didn't remember, we converted that to moles already with a molar mass of 169.88 grams per lonely mole, and that came out to 0.00589 moles. And then the moles of copper depends on how much copper you had that reacted, when you shook it off, if any of it started to break apart. Some people had more copper that reacted, and really it wasn't so much that it reacted as it started to flake off the wire. So hopefully you caught it in time and turned it around to the opposite side of your beaker. That's fair amount of copper to have reacted, 0.22 grams. It would show up on the balance. And copper has an atomic weight of 63.55 grams per mole. So if I took my 0.22 grams or whatever yours, and I'll just put a little question mark here because your numbers are different. But these numbers should be the same. Divided by the molar masses from the periodic table, and I get 0.00346. Maybe with two sig figs, maybe 0.0035. Sig figs are not crucial right here because they've told you they want an integer ratio, so the closest integer. So I'm going to take my 0.00589 moles. That was silver nitrate. And then in the denominator, I'll take my moles of copper, which is 0.0035, and I'll divide and see what closest ratio I get. So 0.00589 divided by 0.0035 equals 1.68 to 1. Now, is that closer to 1 to 1 or 2 to 1? I would say in this case it's closer to 2 to 1. So that tells me for every copper, 2 silver nitrates reacted. Well, if I had 2 silver nitrates reacted, how many silvers were produced? 2. And then how many nitrates? 2. 1 copper nitrate, but containing 2 nitrates. So that means if copper bonded with 2 nitrates that are each a -1, that makes this half a -2, so that makes copper's half a +2. So this must have been copper 2 nitrate. Not because there are 2 nitrates, but because the copper was a 2+. It lost 2 electrons. So the 2 to 1 to 2 to 1 ratio. Or at least that's what I got based on my data. You might want to try a couple other calculations. Maybe your silver to copper and your silver nitrate to silver. We could try the silver nitrate to silver and hope to get, as we predicted, a 1 to 1 ratio. Our moles of silver nitrate reactor were 0.00589, and then our moles of silver, let's say I had the 0.55 grams of silver, 107.87 being the atomic weight of silver, 0.55 divided by 107.87 is 0.0051 moles. Hey, those are pretty close to being equal. This is silver nitrate, and this is moles of silver. So if we compare those two, the moles will cancel, and you get something like 0.00589 divided by 0.0051 equals 1.15, which is going to round to 1 to 1, which is what we predicted. 2 to 2 is the same thing as 1 to 1. I hope this helped. Otherwise, you can do your best and come in and ask questions on Monday.